Round 3, guys. So we want to look at properties of infinite limits and what happens when we try to do strange things with the infinity symbol. So the first one is I have two separate limits. One is going to infinity, one's actually going to a number. And so what happens if I try to add those two particular functions to the overall limit? So here I'm looking at the overall limit of the two functions combined, and I can either be adding or subtracting. And oops, I forgot the little sign over here. So if I'm adding, they continue to add. So that's why notice addition on top, addition on top. And if I'm subtracting, they continue to subtract. And so notice that I can separate them and take the two values and then just sub in. So of course the limit of f of x was infinity, the limit of g of x was L, and if if I take infinity and I add or subtract to it, I still get infinity. All right, let's look what happens when I do product. So again, here I have the product and I'm splitting them. So, oops, I didn't mean to erase, I meant to underline. So I'm splitting them. They still have a product. And so I have a couple of options. I'll get infinity times L, of course, in both cases. But if L is positive, then it goes to positive infinity. If L is negative, then it goes to negative infinity. So that kind of makes sense. Positive times positive gives me a positive. Positive times a negative gives me a negative. Let's see what happens if we try quotient. Okay, getting a little crazy in here now. So I can do quotient either with f of x on top, or I could do quotient with g of x on top. I get different results. So if I put f of x on top, of course, when I split them, I get infinity over L. And if I take a really big number, ridiculously large number, gazillion, and I divide by some value L, it's still going to be ridiculously large. So I'll still equal infinity. Versus if I take some number, now in particular some small number, smaller than infinity, right? And I divide, excuse me, by infinity, then I'm going to get 0. Imagine taking one cookie and dividing it into an infinite number of pieces. We're all going to get crumbs, which is essentially 0. Now, the one thing about all of these is we have to make the assumption that L does not equal 0. If it does, that's going to give us some special cases, and we're going to have to look at the graphs. We can't just use these rules because 0 gives us crazy things, like we can't divide by 0, and over here we'd have 0 divided by infinity, and even doing 0 times, well, not so much this one, but doing 0 times in here gives us some unusual results. We have to look at the graphs. So just make sure that one of those limits is not 0. All right, so let's look at a couple that we'll want to remember in these next two problems. I'm going to erase the board. You might want to pause the video for a sec. So hopefully you remember what the graph of 1 over x looks like. You can always use your calculator right at this point in time to check it. And same thing over here with 1 over x squared. Of course, keep in mind that this is going to square my y values, which is why essentially this bottom piece that was over here is now flipped up top. And so as x is approaching 0, what I notice is from the left, when I get closer and closer to 0, I'm going to negative infinity. And yet from the right, when I get closer and closer to 0, I'm going to positive infinity. And those clearly don't match, so this is it does not exist. However, over here on the positive one, as I zoom in from the left, I'm going to positive infinity. And when I zoom in from the right, I'm going to positive infinity. So essentially this one is positive infinity, although you will come to eventually learn that this one is it does not exist since that's not a real number. But in the event that you have choices that include infinity, you would use the infinity value. It'll be a little confusing. It'll work itself out a little bit later. See you on the next video, kids!